Good afternoon, everybody. This is Mick Zulpo from Apex Instruments. Can everybody hear us?
Yes.
Yes.
Yep.
Excellent. Fantastic. Fantastic. Well, first of all, I'd like to take this opportunity to thank everyone for joining us today. I know everyone's got very busy schedules, especially with our April deadline approaching, but we do appreciate the time you're going to spend with us today, and hopefully it will be very informative for everybody. As we all know, April is very much fast approaching, and many people in the industry are still contemplating their approach to reporting mercury under this MATS rule that we're facing, whether it be SEMS or sorbent trap monitoring systems used for that reporting tool. Today, we plan to present to everybody the range of Apex sorbent trap monitoring systems and how we think this proven, simple technology might be the right solution for your MATS mercury requirements. So first of all, I just want to discuss what our motivation for holding today's webinar is. As some of you may or may not know, I know a lot of you guys have joined us previously in the last couple of months, but this is our third webinar in a series dedicated to the MATS rule with specific focus on the mercury regulation under MATS. The previous two presentations have focused more on the legislative aspects of the rule, getting to understand what is required of it, and those really boil down to specifically lead tester or the low emitter of electrical generating units that's available to some people. And that requires 30B testing to become compliant with the MATS rule. And then obviously we have our PS12B testing for reporting under the MATS as well with sorbent trap monitoring systems. If you were unable to join us for those presentations, we have posted them on our YouTube channel, and they can be viewed at the link there on the screen, or if you just type in Apex Instruments Inc. into YouTube, you will find our channel and the presentations will be there. After sharing with everybody our knowledge on the regulations affecting our industry and sharing our experiences too we've had with this, we thought it'd be prudent to introduce our line of sorbent trap monitoring products that can help utilities comply with the MATS rule and report their mercury levels as required by the legislation. My name is Mick Zulpo, and I'm the Director of Sales and Marketing here at Apex Instruments, and my role today will just be facilitating this webinar. In the room with me here, I have our Director of Business Development, and his name is Mr. Chris Green. Say hello, Chris.
Good afternoon, everyone.
And over the past few years, Chris has been focusing on our range of mercury products, and I'm sure many of you might even know Chris from meeting him at some of the trade shows we've been attending, or by Chris actually coming out and making a site visit to where you guys are. Also joining us today is Mr. Jim Cothran and Mr. David Allen from our technical service group. Say hello, gentlemen.
Afternoon. Good afternoon.
Jim is the manager of our technical support group here at Apex Instruments, and he has been intimately involved with the development and support of our sorbent trap monitoring systems for several years now. David has been with Apex for 8 years, and he is our lead field service engineer for our sorbent trap monitoring systems. David has spent countless hours performing on-site field maintenance, installations, and troubleshooting. The format of today's presentation will be as follows. First, Chris is going to present an overview of the 3 different sorbent trap monitoring systems Apex has to offer. He will be covering our 30B system that is used for 30B, RADA, and lead testing. Chris will also cover our 2 continuous sorbent trap samplers, the XC6000 and the STM12B, that meet the requirements for sampling under the MATS PS12B regulation. Chris will take about 30 minutes to show you all these products, after which we'll open the seminar to questions about our systems, whether they be technical, operational, configuration, or field repair and maintenance questions. I will assist in facilitating these questions and direct them to Jim and David for answering. We do have quite a few people on today's webinar, and we will do our best to open the webinar up for questions over the voice link today. However, I would like to offer that anytime during this presentation, you can email me questions, and I will be happy to present them anonymously during the Q&A portion of this presentation. If you would like to do this, you can see my email address there on the screen. It is mzulpo@apexinc.com, and I'll be monitoring those incoming questions as Chris is presenting, and we'll get to them after he is finished. If we do have time constraints and we don't get to all the questions that we'd like to address today, we will be sure to address them via email after the presentation. Before I hand over to Chris, I just wanted to share with everybody a little history about Apex Instruments' experience with the Sorbent trap monitoring system market. Here at Apex, we've been manufacturing Sorbent trap monitoring components and systems for over 20 years. Since the introduction of the original Clean Air Mercury rule back in 2005, Apex Instruments has placed over 300 Sorbent trap monitoring systems in the U.S. domestic market, most of which are still operational today and are being outfitted for use with the approaching MATS rule that's again coming up in April. Now I'm going to hand over to Chris Green, who will be presenting our line of Sorbent trap monitoring systems. Over to you, Chris.
Thanks, Nick. Good afternoon, everybody, again. I'm going to start off, I want to take you through what Sorbent trap monitoring systems are all about. They capture the total vapor phase mercury concentration in the flue gas, and after analysis they provide a measurement in micrograms per dry standard cubic meter. Method 30B is the reference method for relative accuracy test audits, RATAs, and may be used to determine compliance for a mercury SEMS or a continuous Sorbent trap sampling system. It is intended for use under relatively low particulate conditions. Most long-term runs have been with PS12B trap configuration, 3 sections with spike in the 3rd section. For Lee testing, you may need to carry out engineering runs prior to the 30-day trial, before attempting 10-day runs. For Lee evaluation, runs may need to be shorter but of equal time duration, for example 5-6-day runs. Known volumes of flue gas are extracted from the stack through paired in-stack sorbent media traps at an appropriate flow rate. For each test run, it is always paired samples which are required to determine measurement precision. For PS12B, each trap will be spiked. The image on the screen is taken directly from Method 30B, showing a Sorbent trap monitoring system. We've added a picture of the Sorbent traps here for a point of reference on the system. To give everybody the basic understanding, sample gas is pulled through the set of traps at the end of the probe, which is inserted into the stacked gas stream. The mercury is collected on the carbon media within the traps. The sample gas then flows through the probe, down the heated line, to a moisture knockout system, creating a dry sample. The sample is then sent to the dry gas meter, which records the sample volume so it can be compared to the volume of mercury collected to produce a time-weighted average value of the mercury in the source. PS12B also states that sampling must be performed proportionally to the stack flow. This is simply done by taking a flow signal from the source, sending this to the control console, allowing the system to then adjust the sample rate based on the flow rate. For both Method 30B and PS12B systems, they operate very similar, and we try and keep both product lines as similar as possible, utilising the same component parts wherever we can. We are able to offer different packaging, different configurations, different materials of construction, different probe lengths to meet site-specific requirements. A picture here of a typical 30B sampling installation, showing the probe mounted on a monorail, the quick release camlock flange, the sample umbilical, down to the control console. The automated console, you can see here the temperature input panel down at the left hand side and the paired totalizer displays. PS12B specifically states each sorbent trap monitoring system shall be continuously operated and maintained in accordance with the performance specification PS12B. The QA/QC criteria for routine operation of the system are summarised. Each pair of sorbent traps may be used to sample the gas for up to 14 operating days. However, in our experience, it is more common that we see sample runs of 7 days, as particulate matter build-up and other factors prohibit most sources from running for 14 days. Validating mercury measurement systems. The Ontario Hydro method, Method 29, 30A and 30B are all acceptable reference methods. We would suggest, though, that 30B is the simplest method, and taking into account that PS12B is based upon method 30B, it is almost identical to a continuous sorbent trap monitoring system. Other specification details for performing a rata are the rata must be performed at normal load. A minimum of 9 runs must be performed during the rata. However, up to 12 runs can be performed to allow you to discard 3 runs. Keep in mind, though, that the 3 rejected runs must still be reported. Each run must be long enough to collect sufficient mercury mass on the carbon to be analysed. Sampling time is determined by the source concentration of mercury. Ratas must be performed annually with similar sorbent material as the reporting system is using, which in theory really means using the same traps. Typically, the traps used on a 30B rata are 2-bed traps and cost less than the 3-bed PS12B traps. The rata must be performed on an annual basis. Significant features from PS12B are: the PS12B system is designed very similar to the Method 30B system, but it's able to sample continuously. The location of the sorbent trap monitoring system, or where it will sample, is in accordance with Method 1. The trap spike must be within plus or minus 50% of the estimated mercury in the source. PS12B also outlines the specific QA/QC requirements for running a sorbent trap system. Pre- and post-leak checks must be performed at the beginning and end of every run. Proportional sampling must be within plus and minus 25% of the stack volume, and also the spike recovery and quarterly audits. Another notable aspect of PS12B is that you are required to perform a Method 4 determination of stack gas moisture in conjunction with the PS12B test. You may have a continuous moisture analyzer. Facilities under Part 75 are also already running moisture determination. We have asked EPA to allow us to do volumetric determination of the stack moisture by using the condensate collected by our system while performing PS12B sampling. EPA allow this moisture determination under Method 30B for lead testing, so we hope for a similar response for PS12B sampling. As you can appreciate, the development of the MATS rule, the requirement to be able to determine means to measure, has been a long time in the making. At Apex Instruments, we've been manufacturing source sampling equipment for 26 years, and we have a long history with the design and development of mercury sorbent trap samplers. Sorbent trap monitoring systems are an alternative to continuous analyzers, a method to capture a sample of the stack gas, separating the mercury for later analysis for the standard developed by the EPA, offering a much lower cost option for mercury measurement and compliance reporting. The tester, though, should have a knowledge and understanding of stack sampling methods, including method 30B. If we look at the key advantages of sorbent trap monitoring, a system is quick and easy to install, and importantly, no calibration gas requirements. The system is certified by a rata test using a method 30B system, but a sorbent trap monitoring system offers a significantly lower cost option for demonstration of regulatory compliance. So, a pair of 3-section sorbent traps sampling continuously for typically 7 days. The system comprises a dual trap probe, sample pumps, heated sample line, a control console, sample moisture removal, and high integrity test data collection. A typical picture of the system hardware, although there is great flexibility in the equipment packaging to suit the process conditions and the test location, which I'll just touch on a little later. The test is always by paired sample trap collection. Sorbent traps conform to PS12B sampling and analysis specifications. High concentration of iodine deposited on acid washed activated carbon ensures extreme mercury capturing capacities without breakthrough for extended test periods in wet or dry stack emissions from coal-fired power plants. The trap configuration. Section 1 provides primary capture of the mercury. Section 2 for monitoring of the mercury breakthrough. And Section 3 is the spike section, which is monitored for spike recovery, spiked with a level of mercury close to what we would expect to see in the stack. The trap analysis. Each carbon section is analysed separately. There are different analytical techniques available. The most common and quickest is thermal desorption. The total mass of mercury in the sample is the mass of section 1 added to the mass found in section 2.
Thank you, sir.
The initial rata certification is well described in PS12B. Most importantly, using the same sorbent media for the 12B system and the 30B rata system. For a valid test, both traps must meet the QA/QC tolerance requirements as specified in the method. The sampling location must be representative of the stack gas conditions and free from stratification. A pre-test leak check and proportional sampling to within plus or minus 25% of the stack flow rate, which is recorded in the test data file. A typical view of sampling underway from the source, normally via a 4-inch or 6-inch flange, illustrating the probe into the stack gas and showing the cam-lock quick release technique for inserting and removing the probe. Important for the QC aspect of the sample run that the trap ID is recorded. The system software actually prompts you to about 3 times to record the trap identification data into the test file. But as a tester, it is always useful to carry a small notebook and manually record your activities. From the standard, the analytical quality guidelines provide guidance on measurement, breakthrough tolerance levels, and spike recovery. Similarly, the tolerance levels. The standard also provides guidance on the relative deviation of the analytical result between the paired traps. So, for each measurement run, the paired traps must pass the pre- and post-leak check. They must comply with the breakthrough tolerance and the acceptable spike recovery levels, and proportional sampling throughout the test duration.
Can you please go into Empower?
For a successful measurement, we have to meet the QA requirements. But the standard does guide us what to do if only one trap meets the QA requirement. If we only have one trap with valid analytical data, we can multiply that value by 1.111 to enter as the missing trap data for reporting purposes.
This is your goal. Right. This is...
Sampling system itself must pass a quarterly audit. The critical temperature sensors are checked to a reference temperature. The dry gas meters calibrated against a reference flow device. The whole procedure takes about 1 hour. The reference flow device must undergo an annual calibration recertification.
We set it up differently here. Like
Sample traps are easily inserted into the probe, as shown here. The weekly 7-day trap change should take about 20 minutes. However, we generally recommend that the profile runtime is set to longer than 7 days, perhaps 10 days, just in case you cannot get to the sample location to change the traps. For example, the elevator breaks down or personnel are absent. Seen here, you'll see that some sources can offer a challenging environment, continuously extracting a sample. High particulate, wet FGDs, lime injection are some of the challenges for 7-day sampling. Right trap configuration to suit the sampling environment. Particulate, acid gas and moisture can cause sampling issues. This is where trap configuration can help with process conditions. Additionally, trap shields can protect each trap. An illustration of the individual trap shields, ensuring no restriction for the pre- and post-leak checks. As mentioned, it is always a dual trap probe and perhaps a trap shield assembly. Each side of the probe is identified as A and B. As a guide, always insert the lowest numbered trap into side A. Normal sampling and temperature of the stack is up to around 300 to 350 degrees Fahrenheit.
Which has got the same info, except now we come down.
Sample profile can be configured to suit the measurement location. It's an additional aid to a successful measurement program.
How much of it is complete? So it's like mid-year?
Moisture has to be removed from the sample. We chose the high-performance Stirling cooler for its ability to work in extreme temperatures, high summer temperatures and winter temperatures, which can be a little chilly in places.
If you've already done more, or let's say at the end of the year you've done, it says to do 3 things, you've done 5, you can live.
Packaging of the Sorbent trap control system. Generally we have 3 variations: a portable, a 20U enclosure and the wall or rack mounted unit. From a 20U housing, as previously seen, to the smaller footprint wall or stack mounted cabinet where space may be at a premium, or if space in the elevator accessing the sampling platform is an issue. We've listened to our customers and developed a smaller footprint rack or wall mounted control console, keeping the same functionality as our XC6000 units. Not only a smaller footprint, we've taken the opportunity to incorporate some innovative design changes. A touchscreen display permanently mounted on the swing-out control console door, and a smaller chiller. As mentioned, rack or wall mounted where space might be an issue, the unit is with its own air conditioning and heater unit, which chose the unit for extremes of operating temperatures, down to -25 and up to 130 degrees. The control console swing-out door makes for easy access to dry gas meters, the DAC and MUX boards, all at a nice workable height. Each package variation offers the same operational functionality to meet the requirements of PS12B. A typical installation for a 12B Sorbent trap system, mounted at the stack, the location within an annulus, the sample probe and control console mounted fairly close together. Typically, we have 3 system configurations. Our most common installation is everything at the stack sampling location. A second configuration illustrates where space might be an issue, and just the probe and moisture removal are at the sampling location, with the control console down in the SEM shack. And our third configuration is just the sampling probe at the sampling location, a heated junction box, a heated sample line, bringing the gas down to the SEM shack prior to conditioning and volumetric measurement. Key features of an automated PS12B type system as required by the standard: fully automated paired sampling, everything from the pre-leak test, the whole of the sample run, documenting everything that happens, integrated temperature control of the key components throughout the system. I think perhaps the most important, high integrity data collection, making sure that none of the test data is lost for any reason. The control software, once installed on the laptop, is accessed by an icon on the computer desktop. The main screen and connection to the console, and then guiding the operator to the next screen, is by a highlighted next step box. Each screen, all of the steps to operate in the system, follows the same intuitive highlighted box, guiding the operator through the system. The test profile records all of the general information, which once added doesn't often change, but the profiles are easily added or edited. For example, if the test run duration is changed, or any of the control temperatures or desired sample flow rate alters, it's easily accessed. Alarm actions, easily configurable. What happens if an alarm occurs? What do you want the system to do? Do you want it to stop sampling, to stand by? The profile will contain all of the test run information, the sampling location, the stack details. Fully automated leak checks for each test, once successfully completed, will be written to the test data file. The test run parameters and data available during the test can be viewed anywhere over the plant network. The test run data file is written to one of 99 memory slots, easily accessed, easily downloaded. At the end of the test run, another fully automated post-leak check. Once again, when it's completed, the test data file is updated, and this is a good time to download that file. The test data file is easily exported, either as a text file or a CSV file, but also the test run data being passed into the plant data acquisition system, ready to be forwarded to the EPA via the ERT route. A quick summary of the PS12B standard QA/QC requirements. For sampling, we must carry out leak checks before and after. And the system must operate proportional sampling relative to the stack gas flow. With the analysis, the trap IDs are required, tolerance on the breakthrough, tolerance on the spike recovery, and tolerance of the relative deviation. We must carry out a quarterly audit, and we must carry out an annual RATA test. Well, for me, that's a very brief overview of sorbent trap sampling. It's relatively simple, but it's proven, tried technology. It's been in use for stack sampling for many years, but meets the requirements of the performance standard PS12B. As Mick mentioned earlier, we have over 300 systems currently out in the field, and we've been making this product range for over 8 years. I'm now going to hand you back to Mick, who will guide us through the question sessions with Jim Cothran and Dave Allen. Thanks very much.
Thank you, Chris. Can you go ahead and unmute everybody? Thanks for your time, everybody. We had to mute everybody there just so everybody could hear us, but we've had Chris go ahead and unmute everybody. So I'd like to open the floor to any questions that you'd like to pose to us. We'll go ahead with that before we start addressing any of the email questions that we've received so far. So I'll open the floor to everybody. If anyone has a question, please go ahead.
Hello.
Hello.
Yes, this is Hashmukh from FL Smith. We are a DES. We also have our DES system to connect with all your Apex instrument and collect all the data and do the further processing. Have you prepared any document or which will be useful for implementing the integration with the DAS systems?
We have basically, essentially, you're talking about a Modbus interface and a list of all the registers?
No, that I'm aware of it, and we have it, all that. But once when you showed this data file and all the columns of data and all that, but that is somebody has to manually interpret that, right? To decide whether the trap is valid or not valid, or is there anything which comes on the Modbus which says the trap is valid for both the pair of traps have been valid?
The data is in the Modbus interface, but as far as being valid, are you talking about after the analysis is done?
Yeah.
Okay, that's pretty much after the fact. I provide you all your temperatures, pressures, and volumes that are used. The actual trap analysis will be coming in at a later time. That has to be manually combined, if you will, with the calculations in the method to show what your concentrations are, your deviation, etc.
Mm-hmm. And this instrument for measuring the traps, is that provided by your company or?
No, you're talking about a mercury analyzer.
Okay, so you don't have any mercury analyzer product, right?
No, we do not.
Okay.
Into that one on the analysis.
Oh. Okay. Yeah, I guess Mike's got a question regarding the cotton. Yes, it does. As far as it needs to be analyzed also for any collection.
All right, we'll address maybe some of these email questions that have come in here real quickly. One question that's come in is, are there any other scheduled maintenance operations that you suggest other than the quarterly audit on our systems?
There's not a specific schedule. Typically, what we recommend and we've written up for our customers is that when you change your traps, which is on your weekly basis, that's the time you want to visually inspect the system, make sure you empty your condensate bottles, check your scrub cartridges, and depending on the stack environment, a lot of times we'll have them actually wipe down the probe, that type of thing, but it's mostly just physical part, and it's done during trap changes. When you actually do your quarterly audit, it's a good time to do a good internal visual inspection because you're inside the console, checking for tubing, any corrosion that you notice, anything like that needs to be addressed. And that's about it, really.
Okay. There's been another email question here with regards to remotely controlling or monitoring the system when you have configuration 1, which, if you remember from our slides, was having the unit up at the stack location.
Yeah, the console itself has internal Ethernet connections which will allow it to, one, you'll have a local Ethernet port on the front of the console which is used for maintenance, trap changes, starting up tests, etc. There's also a network port or a WAN port on the rear of the console that can be connected to your plant network. So from a SIM shelter or depending on what your entire network setup, you have full access and can monitor the system actually you can do partial exports of the data file at any time and see it from there. But it's basically it's an Ethernet interface.
Okay. We do have a couple more email questions, but I'd like to open the floor to any voice questions if anybody would like to chime in and have a question for Jim or David.
Yes, I have one more question here. During the test run period, when sorbent trap sampling is going on, if there is a fault develops in your system, any type of flow failure or any cooler any type of failure, does it actually invalidate the traps from that point onwards, or can that be used after correcting the failure?
It depends. It gets a little complicated. It depends on what the actual failure is. The system itself has built-in alarms, so certain things can pause the test, so will not continue. One example would be is if you're in a high particulate stack, you plug up your traps and they cannot maintain proportional flow anymore because there's just too much buildup on them. We can actually pause the test at that point. You'll be valid up to that point. That will also raise alarms back either through your Modbus interface or external alarm connections down to your control center to notify someone that needs attention.
No, I mean, in the situation where the whole system is remotely controlled on the Modbus, where we give the command to run the traps and run the test period and pause the test period and all that.
Yes.
Okay. Does the system by itself, would it also pause in that situation or no?
It can. If you set the alarms when you do your profile, you can set an alarm and say, okay, if my vacuum gets over a certain amount, pause the test. If a temperature gets out of range, pause the test.
Okay. And all the checks which are there, they are like, are there certain checks which cannot be overridden by any user, or is it completely open to the profile configuration?
It's open to the profile. When you set up your test is when you specify your actual alarm and alarm conditions.
No, like from compliance purpose, is there any built-in checks which can never be overridden by any user?
Well, I'm not sure if I quite follow you. When you basically within the test itself, you set up your parameters of how long you want it to run, what sample rates you want to run, etc. If you do make any changes to alarms or override an alarm or anything like that, all that data is in the exported files.
Okay.
Show you that someone has done something.
Okay.
I'm not sure I'm not sure if I answered your question correctly or not, but everything you do is tracked, in the console. So there's certain things you can't change, you don't have access to, but most of your alarms and parameters, etc., you do.
And you said something like 99 memory slots. Is that like 99 trap test periods is what you meant?
Yes. And that's not a maximum. The internal memory can hold 99 different tests, if you will. But typically you can overwrite them, erase them. They're just memory locations. Normally when you would set up your test and complete your test, you would go ahead and export your file onto your PC, and so you could have it and combine it with your analysis at a later time. But you can leave them on the console as another backup, if you will.
Okay. And this is like on the laptop that you provide, right? With it. When you said the console,
we can provide a laptop, or it's any standard laptop running Windows operating system.
Okay. Okay.
We don't force you to buy our laptops or anything. And also, I think I saw another email question regarding licensing. While we're on the subject, is the PC application portion of this comes. The licensing is tied to actually the console itself. So if you buy an XE6000 console or a 30B or one of the other ones, you have the right to install that software on any PC, or if you're running some kind of terminal server to access that console. So there's not additional PC licenses, if you will.
Okay. Thank you.
We had a couple of written-in questions here we'd like to address real quick. The first one is there documentation available identifying the Modbus register?
Yes. Yeah.
Okay, and we can make that available to anyone who may need that. Jeff's got a quick question here. I guess they've had a couple of issues with the dry gas meters on a 6000. When you take a look at the test data, how can you tell whether there is a problem with the meters? Are there specs or other performances that performing an audit and using an audit spec?
Just reviewing the data, typically if you have a meter that's giving you a problem, comparing the data and the volumes on both sides, you can usually spot that. Audit is a surefire way to make sure the gamma numbers are within tolerance.
And what would you suggest if you do see an anomaly between those two gas meters, Jim?
Usually you run an audit to confirm it before you start changing parts.
Okay. Okay. Fantastic. Does anyone else have any questions through the audio link? It looks like we've pretty much answered everything here. I'm just reading through a couple more that were duplicate questions here that we had. There was a quick question here about probe length, and this might be from coming from our Lee webinar testing. And just to expand on that a little bit, that Lee 30B testing requires that you sample within the centroidal area of the stack, which is the middle 10% of the stack. So that often requires a longer probe when you're doing Lee testing rather than regular 30B testing. For example, the math works out if you had a 30-foot diameter stack, you would need a 10-foot 3 probe to be able to test in the centroidal area. So that issue has been coming up a little bit, and we've been trying to educate people on that. As terms of PS12B, the regulation states that you only need to be 1 meter away from the stack wall inside. So typically a 6-foot probe would be more than enough to be able to handle those. And we make probes in all different lengths and sizes, as well as the monorails to suit what you need as well, because we know some people have space limitations with annuluses and things like that. So if there's no other questions, I'll pause for a minute to make sure no one else had any questions.
I have a question. With the moisture monitoring, are you seeing a lot of sources going with the moisture monitor, or using the default moisture or moisture lookup table as an option?
Most of the ones that I've been on site and deal with use a moisture table or enter a constant value. Yeah. The console itself will accept a moisture input, but it's really more just to record that data along with the run data. It's not used in internal calculations because the dry gas meters in there, they are dry because you're after your scrubber, so it's actually giving you a dry volumetric measurement.
Right.
And some states require wet reporting. That's why the moisture is available to be put in. But that's kind of done on the back end when the analysis is combined with the test run data.
Are there any other questions that we could answer? Fantastic. Well, I'd like to thank everybody for spending your time and joining us today. What we're going to do is we've recorded this session, and we're going to put it on our YouTube channel if anyone would like to go back and review the information that was shared today. Also, if you'd like to see a copy of the presentation with our speaking notes, just drop me an email, mzulpo@apexinc.com, and I'd be happy to share a PDF version of that with you. Also, we'd like to offer that Chris and myself are available anytime to further expand on and get you more information on our products, and we're also available to do field visits, demonstrations on-site or remotely, and also some site evaluations to see if our application may be relevant for what you're trying to do by September's deadline, April's deadline. Thank you again for everybody for joining us, and we hope to hear from everybody soon. Enjoy your afternoon.
Thank you.
Thank you.